In the previous video, we just proved one of our sum and difference formulas, and let's just assume that we've proved them all now, okay? And so what might be helpful for you is to have these readily available, okay, on a sheet. And what I did was, just to show you what I have, I just copy and pasted, and I have like that unit circle that we looked at before, and then I have my fundamental identities, and now I have my sum and difference formulas, okay? And that might be helpful for you to have on a sheet as we build our library of identities. All right, so let's take a look at some examples as to where we're going to use these various sorts of identities. All right, so the first one we have is we have cos of 65, cos of 5, sine of 65, sine of 5, and we're adding those together. Now, if we go onto the sheet that we look at, we're looking for the pattern cos, cos plus sine, sine. And I want you to notice that this is the same and this is the same. So let's call this x and let's call this y. And let's call this x and let's call this y. So we're looking for something of the pattern cos x, cos y plus sine x, sine y. All right. And if we can find that pattern, then we might be able to do something to where we can evaluate this. Okay. So if we go into our formulas, again, cos, cos plus sine, sine, and we notice right here that we have cos, cos plus sine, sine. Okay. And that's equal to x minus y. Okay. So we know that that's going to be equal to cos of x minus y. And in this case, we said x was 65 and y was 5. So this now becomes the cosine of 65 degrees minus 5 degrees, okay? Or the cosine of 60 degrees, right? And of course, we know that the cosine of 60, we should have these absolutely memorized by now, but the cosine of 60 is just going to be a half, okay? And just in case you don't have these memorized, although we absolutely should, we want to go into our unit circle. And remember, we look at 60 degrees and we look at the x coordinate. Okay, so that's a half, just to remind you how to get there. Okay, so that would be an application of using our sum and difference formulas. Okay, in a similar fashion, now notice we have sine cos, cos sine. Okay, so let's call this pi 12ths x, and let's call this 7 pi 12ths y. And so we're looking for something of the pattern sine x cos y plus cos x sine y. All right. And of course, we know that these could be flipped around. Okay. So it might be like another way to write that might be like sine x cos y plus sine y cos x. All right. So we just basically have to see a formula where they're flip flopped around and a plus in the middle. Okay. So if we go here, we take a look and we notice that we have sine x cos y and then cos x sine y. And that's equal to sine of x plus y. Okay, so again, sine cos plus cos sine. Okay, so, and that gives us exactly this one. And again, that is equal to the sine of x plus y. Okay, so that's our sine of x plus y. And so that's going to be now the sine of pi 12ths plus 7 pi 12ths. Or if we add those together, that's going to be the sine of 8 pi 12ths. If we reduce that, they both have a common factor of 4. So that's going to be the sine of 2 pi thirds, right? And again, we should be able to evaluate this by remembering that this is a reference angle of pi thirds in the unit circle. And also remember that the sine function is positive in quadrant number 2. So this should be equal to the square root of 3 over 2. Of course, we can always verify that by looking at the unit circle, remembering that the sine is the y coordinate. So we just go to sine of 2 pi thirds, all right, which is right here. We look at the y coordinate, and that is the square root of 3 over 2, all right? We have this tangent, okay? We want to try to determine what the exact value of that is going to be, all right? So this looks a little ugly. So we have something to the effect of tan, and let's call this x, the 2 pi fifths, and let's call 7 pi 20ths y. All right, so we have tan plus tan, 1 minus tan xy. So really what we're looking for is looking for a formula tan x plus tan y divided by 1 minus tan x tan y. Right? And so if we go back into our formula sheet, okay, it looks like that this is exactly going to be the formula. Tan x plus tan y, 1 minus tan x tan y. All right, and that equals tan of x plus y. So we're just going to have to add these together. And so this is equal to tan of x plus y. And so this is now going to become the tangent of 2 pi fifths plus 7 pi 20ths. Right? That's the same as if we got a common denominator, we would multiply the first by 4 in the top and the bottom. All right, so we would just multiply this by 4 over 4. Right, and so now we can start to combine this a little bit. All right, and so that's going to be equal to our tangent of 8 pi 20ths plus 7 pi 20ths, or that's the tangent of 15 pi 20ths, which is the same because they have a common factor of 5 as the tangent of 3 pi fourths. Okay, now remember, tangent is y over x in our unit circle. Okay, so if we go to our unit circle at 3 pi fourths, okay, we notice that y is going to be root 2 over 2, x is going to be negative root 2 over 2. Okay, so this is going to become root 2 over 2 divided by negative root 2 over 2, which is just going to be negative 1. Okay, so that's how we can go through and evaluate some of these really fundamental sorts of ideas by using our sum and difference formulas. All right. So in our next video, what we're going to do is we're going to prove a few basic identities, okay, and then we're going to move on to some more difficult types of problems with sum and difference.